Hello, everyone. Welcome. Good morning, good afternoon, good evening, wherever you are tuning in from. I'm Jenny DiFigoretto, the community manager for DVC. Today, I'm really excited to bring you this panel discussion. This is the first time I've done one of these, so I'm really excited about it. I have these great guests that have a variety of perspectives on reproducibility and standardization and how that helps with complying with regulations within the industries that they're in, and how to create those systems in their work. So I'm just going to jump in and get started, and we'll start with introductions. I'm going to have each of them introduce themselves and give a little bit about their background and what they do in their current role. And we'll start with you, Alex.
Great. Well, I'm Alex Hasha. I'm currently a freelance machine learning engineer and data scientist, working to help my clients make their model development processes more efficient and trustworthy using software automation strategies. And I previously led a model risk management program at Capital One, where I was responsible for peer review and validation of emerging machine learning use cases. And that's really where I learned firsthand how hard it is to establish trust in your models if you don't build them in a way that's reproducible and transparent. So this panel topic's right up my alley.
Perfect. Let's go to you, Estefania.
Hello, everyone. My name is Estefania Barreto Ojeda. I'm currently a machine learning engineer at Recursion Pharmaceuticals. I'm part of Kernel AI, which is part of the operating system of Recursion, where we build, test, support, and improve machine learning models that pretty much drive the technology that Recursion uses for drug discovery. I started my career actually in academia, so I'm a physicist by training, but I jumped to industry, and yeah, I am now working as a machine learning engineer.
Cool. And Charles?
Yeah, I'm Chuck Vardaman. I am a computational scientist / research assistant professor in Notre Dame's Center for Research Computing. The Center for Research Computing is essentially the holder of the HPC, high performance computing for Notre Dame. But we also do what's called cyber infrastructure development, right? And so this is building tools for science and academia that answer questions. My background is actually in theoretical chemistry. So I started in life building actually software to do theoretical chemistry because the existing software didn't exist to answer the type of questions I wanted to answer. So we were model builders. And one of the things that my advisor was very concerned about was open science, and he founded actually openscience.org, because in order to apply the scientific method to a model, you have to be able to falsify the model. And that means that, sort of 2000-ish state of the art was there were open, sort of downloadable binaries, but there wasn't something that you could go into and understand how the algorithm produced the particular answer that you're trying to make a scientific statement based on. And so we decided we didn't want to, sort of follow that route. We want to be open and transparent. So we created software that's now in Git called OpenMD that does this. We use proper software engineering and version control and all these sorts of things, regression tests so that it's trusted. So when we make changes, we go back through known cases, make sure that they were, satisfiable. And we also created a metadata sort of standard that went with the simulation, because previously these simulations were based on Fortran cards and they were completely opaque, right? You had no idea what the sort of positions and the rows and columns meant, right? And so we wanted something that basically said that this is a chemical system and this has the components and all this sort of stuff, so that anyone that looks at this that's a chemist can immediately know exactly what the thing is doing underneath the hood. That's extended out, right? And so now, as part of the Center for Research Computing, I'm interested in how we can use AI to help with this. And as part of my trusted AI effort and CI Compass and all these sorts of things, how can we use these things called knowledge graphs, which are sort of the rage now with retrieval augmented generation and language models, but been working on using this knowledge graph sort of approach for well over, I think, 12, 13 years now.
Wow. Cool. So I would like to say to the audience too, I have a bunch of questions that I'm going to go through with the guests here, but if you have any questions, by all means, put them into the chat and we can bring those up at the end too, if you have anything that comes to mind. So the next question that I had for you is, what kind of regulations are you currently grappling with, if any, in your industries? And there's going to maybe be some things that you can't talk about because of your companies. That's totally okay. But in general, I want to know like how regulations in general impact your work and how you have to think about it. For this one, let's start with Estefania.
Yeah, so recursion is pretty much focused on industrializing biology. Pretty much the mission of recursion is to industrialize the drug discovery. So, of course, our industry is highly regulated, and of course, we want to be compliant, but also because our mission is to industrialize drug discovery, we want to be also efficient. Now, these regulations, what translates to me as a machine learning engineer is in how regulated the data that I work with is. Now, this is related to the part of data governance, which of course is not universal because this definition is different according to the nature of the data and what type of industry we are. But pretty much what happens in recursion is that we're generating a lot of data, and we're probably one of the companies that generates the largest amount of data. And in this context, there are several things. Well, the first part is that we're bringing drugs to the market, which means we need to be able to reproduce key findings from raw data. This means that in our industry, reproducing key results is fundamental. So what translates these type of regulations is that also we have some data governance that is controlling the ability to have reproducible results. Now, another dimension of these regulations, it's related to security, of course, the fact that we need to control who accesses the data and how we control that entry of data. There is another dimension in this regard in TechBio in general, which is related to the ability of have fine control of especially partnership data. So in TechBio, it's very common to have partnerships with different teams. And this is very important for us in recursion because we are very careful and very respectful of the data we handle with partners like Bayer or like Tempus, just to give some examples. And we have in place strict practices to avoid any sort of data breach. We have data strategies in place to guarantee that to our partners. But again, those regulations that are then, it's we have different layers. We have this control and security. But it's not only there, because also when we talk about accessing this data in the TechBio ecosystem, what we are trying to do is also to build autonomous cycles, because this is just important for us. All our decisions are data-driven, so pretty much all these regulations end up being how highly regulated our data is, how highly standardized it is, how customized it is, depending on the needs. So this also translates in something maybe we can talk later, but pretty much all these regulations in my day-to-day job translates to how highly regulated the data is.
Mm-hmm. Excellent. Cool. Okay, Alex, you're next up on that one.
Great. So the regulatory framework for machine learning and AI and financial services was established in 2011 in the wake of the financial crisis by the Federal Reserve and the Office of the Comptroller of the Currency, or the OCC. And their main concern when that was being developed was banks that are too big to fail, putting their solvency at risk by excessively trusting inaccurate models, right? And as you can imagine, in 2011, that was not a hypothetical concern. And to summarize the regulatory framework in one sentence, they required independent peer review and validation of any model being used by a bank. And their definition of model was really broad. So there wasn't a lot of machine learning and AI the way we currently understand it in banks at that time, but the way they defined it as those use cases started being more common, they fell within that framework. And the key thing in financial services is that the scope and depth of that peer review and validation is risk weighted. The more the model has the potential to harm the bank, the more evidence that you have to produce that the model is correct. And so, if you're going to do, a fun chatbot that doesn't make any financial decisions, that might be very, very limited oversight of that. But if you're going to use a model to take $50 billion of exposure over 10 years, then there will be a lot more documentation and scrutiny, right? And so I think this is a great principle for balancing innovation and safety, regulating AI in any domain, but it does require putting in a lot of effort up front to do those risk assessments and be honest with yourself about what are the risks if this use case goes awry. It's often people are focused on the prize and not thinking about the unintended consequences or the failure modes.
Yeah, good, really good point. Risk assessments. Think of the consequences beforehand. I think that's really important. So Charles, let's have your input on that.
Yeah, so if you're a federally funded researcher, that's an academic like myself, the big thing in the horizon in terms of regulation is something called the Nelson Memo. So this is from the Office of Science and Technology Policy. It was issued in 2022. And what it says is that by December 31st, 2025, all data and publications funded with federal dollars, so this is National Science Foundation, Department of Energy, Department of Defense, NOAA, any organization that's a federal agency that funds research, that those have to be publicly accessible. And that they have to be essentially free. And there's other sort of guidance that goes along with it in terms of what structures the data should have, right? So this is all data centric, right? Which is sort of this reoccurring sort of theme, as well as the models, right? So it's the data and the models that are important. So as part of CI Compass, so CI Compass is a cyber infrastructure center of excellence for National Science Foundation major facilities. They're sort of at the tip of the spear, right? Because those are the high visibility, very big dollars. So think CERN, think of NEON, which is National Ecological Observatory Network. And these are sort of the organizations that we're currently working with to sort of figure this out, right? So how do we release our data? How do we enable our users to release the data? Because sometimes it's complicated. How do we track this information? How do we apply what's called FAIR principles? So a key part of this is FAIR data principles, which stand for findable, accessible, interoperable, reusable. And also there's a subset of those called CARE, which look at the sort of human impact of those sorts of data structures and principles. In any case, the FAIR data principles are sort of all science organizations, DOE, et cetera, are trying to figure out how to apply these things. And essentially, these things are knowledge graphs. So the FAIR paper by Wilkinson, which is the thing that sparked this whole thing, the interoperable part is using things like common vocabularies, common data structures, common schema, using the referenceable persistent identifiers. So things like ORCIDs that then allow you to track who the person was that was involved with a particular set of software or a particular set of data. And so all of those things right now are sort of in this sort of staging phase of how to figure out how to require or not require or encourage adoption, right, depending upon the agency.
Cool. Great. There's lots of info there. And for our listeners, I'm going to be taking all of these things that they're talking about and providing all the links in the description afterwards. I'll update that so you guys have access to all that. So now regarding reproducibility and standardization in your work, I'd like for each of you to explain your experience as related to these things with respect to your industries, and what are the challenges and solutions you've found. Like you've each highlighted different parts and what's important within your own. So what type of specific challenges and solutions you've found for those challenges within those things. And we'll start with Alex.
Sure. Okay. So, I mean, I'll speak from my recent role leading a model validation team. It's just where a lot of my motivations come from. In that role, a lot of my day-to-day energy went into finding out what the teams I oversaw had done to build their models. Right. You can't validate that a model is correct until you know in detail what is the use case, what data was used to build the model, what algorithms were they using. And my responsibility as a sort of internal peer reviewer was to understand in detail what had been done, make sure that it was documented well enough for me to understand it. It would also be documented well enough for business continuity, for external and internal stakeholders to understand. So getting to that sort of level of transparency where validation can begin was the starting point. I would have strongly preferred if that was sort of 20% of the job and the other 80% was the effective challenge, right? The stressing assumptions, evaluating methodologies, challenging their modeling choices. That was the kind of thing that everybody was on our team was excited to do. In reality, it was usually 80-20, where you spend, depending on the maturity of the team, anywhere from a few weeks to sometimes many months, getting to that baseline understanding of what did you do. I came into that role, out of enthusiasm for applying software engineering best practices to work more efficiently in my own work, right? And I had, as part of an innovation team within Capital One, developed frameworks for using like directed acyclic graph scheduling to automate model pipelines from end to end. And I was eager to spread the good word that working this way is both easier and more efficient. And getting into risk management was a way of combining some carrots with some sticks with the carrots, and to get appropriate attention on working this way. But I really think that even in the absence of regulatory oversight, there's really strong reasons to embrace standardization and reproducibility. If only because developing models and analysis is a really we have all these lovely prototyping tools where it's easy to get started these days, but a real analysis that's going to be used out in the world and market ends up being very complex by the end, right? So by the late stage of a model development project, you have dozens of notebooks, hundreds of data files, and as the complexity accumulates, mistakes get more and more likely, right? It's also it's an iterative process, right? We tend, when we build a model for use in market somewhere, we don't just build one, we build hundreds of candidate models, right? So and as we learn more about our data, as we satisfy more and more stakeholders with different graphs and views of the results, you end up with this long sequence of operations that have to be performed in the right order, that you're doing again and again. So as a result, automating those repetitive tasks in a reproducible way is kind of a no-brainer just from an efficiency perspective. So DVC is one of my current favorite tools. It gives me some very important components of sort of lowering the barrier to entry to doing that. But I've talked long enough, so let some other people talk about their experience.
Okay. Well, I had one question in there. So when you were in this role, was this like this? So this was like from the company, an ongoing effort. This was an initiative. It was something that important and was required, or was this like from you? Because how was the organizational culture around this type of work? I guess is maybe what I'm asking.
So at a large bank like Capital One, again, I have been out of there for 2 years, so I don't speak for Capital One. Mm-hmm. But the regulatory oversight of the use of models is very detailed. and robust. So, a couple times a year, the whole model risk management program would be examined by the Federal Reserve and the OCC, and they'd need to see all the evidence that we were running a mature and well-managed risk management program, right? So they were examining not just that the people who developed models documented it well, made good decisions, but that the people who were reviewing the models, were like really challenging them, that we were effectively independent, that we actually had the expertise to do that work effectively. So the documentation that we would write to provide our challenge was also examined. So, I mean, there was an enormous amount of energy that went into it. And the sort of executive leadership, when you get up to the levels where people are non-technical and you don't sort of roll out of bed in the morning with an appreciation of the finer details of analytical best practices, they cared because if something went wrong with this, they could get an audit finding, and that had very real business consequences. So, I mean, I think the default culture was to take it very seriously, and the challenge was to prevent it from turning into some kind of box checking exercise where it's like, what do we have to do to make sure we don't get in trouble? Like, that's the default. To steer it away from that to how do we use this as a vehicle to build better models more cheaply, right? I mean, that's I didn't get into risk management because I wanted to walk around with a checklist telling people what they'd done wrong, right? I wanted to help people be successful, and so I think that the culture there was pretty well steered in that direction. But of course, there's lots and lots of data science teams, and with the growth of machine learning engineering, growth of new machine learning use cases in financial services, a lot of new people coming in that need to be kind of brought into the mindset. So there's a lot of work.
Cool. All right, cool. Hold that thought, because that's going to be into our next heuristic topic. But Estefania, so the same question, like, what are your specific challenges and solutions that you've had for reproducibility and standardization?
Yeah, so I think that being able to reproduce results is an immediate consequence of how standardized the data is. And as I said before, in the context of recursion, pretty much what we want to do is to speed up the process of drug discovery. And to do that, we need to have standardized data, but also we need automation. And with the combination of those two, then we have reproducible results. Now, something very interesting about recursion, something that is very, very challenging working with recursion, is the amount of data that is generated. So we have proprietary data because we run experiments, and then we build our machine learning models based on the data we generate. So it's quite challenging because we have high amount of data, and also that in combination with having best practices in software engineering, it makes our code maintainable, easy to read, easy to fix. If we need a new upgrade or if we need a new feature, having best practices in software engineering is very important. And then I think that probably one of the challenges in the standardization of data is to being able to maintain the data, seeing all the cleaning, having like a very specific cycle for the data when it comes raw to it's ready to plug into the model. And it's not that easy to solve that problem, right? Because as I said, we are generated large amounts of data. So how do we keep track of all the changes in the data? This is a very difficult problem to solve, and something that in Recursion we are doing is to version control the data, because by versioning the data, we can also have control over what are the experiments we're running with very specific models. And then every time we are changing or we are tuning the hyperparameters, we can keep control on that single experiment, and then we can compare. It's really a non-trivial problem, the standardization and the to have reproducible results is not trivial at all, and it becomes even more problematic when we have so much data. And even when we are generating our own data, it's not that simple either, because not because we generate the data, it means that we have only one data source or only one type of data. So probably one of the best ways to have a solution that includes the ability to standardize our data, the ability to automate our data, to then have reproducible results, is probably by versioning the data. Now, it's important also to identify that tools that may solve this problem, it doesn't mean that they are ready to be automated, because what we find is that there are many, many tools out there in the market, but not all the tools are useful to automate processes. And it may sound trivial, but not all the tools offer integration with the infrastructure or tools that are set in place already for us. So we need to also try to find that sweet spot that a tool is offering me all the solutions I'm looking for. Well, I can also plug them into the pipeline and be automated. I'm particularly a fan of automation. And to me, a solution is a solution that works with the minimum amount of clicks. And I try to minimize human intervention to the greatest extent. It's not always doable, but there are some tools that clearly alleviate this problem. And I think by versioning data from the raw data to the moment it's plugged into the model, plus versioning models and versioning experiments, I think that is one way to go.
Cool, great. And so DVC helps you with that, I guess. I've heard you speak on it.
Yes, yeah. We use DVC, and also so we use primarily for data, because, as I said, so we have several sources of data. So we keep control on the raw data, version it, then we clean it, version it, and then when it's ready to plug into the model, third version, and then it goes the process for training.
Cool. And so for how much you've spoken about the data, like what type of scale of data are we talking about, and like how much does it change?
That's an excellent question. So we have data input is usually data generated in a cadence of 1 week. So pretty much every Friday we have new data. And there is a possibility that in the experiments, some of these data changes. So we need to, no matter what, we need to rescan all the data, all the raw data. So that's why in our particular case, automating is so important.
Cool, makes sense. Okay, and then we'll go to Charles. Same question on challenges and solutions that you found. I know you have a framework for this, so this is great.
Yeah, so I tend to think of this in sort of different bins. So the things that you've heard from the previous speakers were what I've been into something called reuse, right? So if you go to fairsharing.org or anything that talks about fair data, right? The R actually stands for reuse. A lot of speakers I've been at conferences where people have said, no, this is reproducibility, but it's not, it's reuse. Okay. And so the part of reuse that's important is provenance, right? And so data versioning, data control, model versioning, metadata around that, so you can understand what the models and the data are doing, all sort of feed into that recommendation. And there's standardized ways of doing this, right? So W3C, same guys that said that your browser renders HTML in a certain way, have actually a vocabulary for doing this. It's called prov-o. And it basically is a way of talking about the things that are in your data, the people, the entities, and the activities that created that data, right? Whether it's a model or a person or whatever. There's something called ML Croissant from ML Commons, which is a organization that is being strongly adopted by AI Alliance. So AI Alliance is a newly formed organization that Notre Dame is part of. That was sort of being pushed by IBM and Meta and all the big open AI players right now. And they're thinking about these things too. But croissant's been adopted by Kaggle. It's going to be likely adopted by Hugging Face as a lightweight vocabulary for describing data sets and how those data sets are partitioned to go into a model, and also describe models and everything along the way. And they're using these other vocabularies, right? And so I can basically set the context for what's going on. All right, so that's reuse. Now, reproducibility and replicability are additional sort of things, and they're a little bit harder. So, and I make a distinction between those and reuse. So, reproducibility is essentially, from a scientific perspective, a sort of statistical result, statistical average, right? And so in molecular dynamics, if I have a model that's, a model of some aspect of the real world, and I measure some property, some average property about that thing. If I'm using one model versus another model, they should tend to that same thing if I'm reproducing something that is fundamental to the real world. Right? Replicability is a little bit more stringent, right? And so what that actually refers to is that I can actually go down into the numbers and start to compare the actual numerical values that are coming out of the model and say that these are exactly the same. Right? That's really hard because you have floating point error, you have all these sorts of things that make it very difficult to exactly replicate a model from one device to another device, right? Because these are all mathematical approximations as operations are done on the device, right? And so the questions that you then have to ask yourself is, which bin am I in, right? So am I in the reuse bin, right? Which I think is sort of the FAIR wisely chose that as sort of the minimum, viable product, so to speak, right? That reuse should be our goal. I think reproducibility for science, for finance, for all these other sorts of things, as I defined it, that they should tend toward, these models should tend toward some accepted value, right? I think that's important. I think that replicability is hard. And that's hard because the models are implemented in different ways. And if you're checking, naively checking, my students do this, right? They naively will go, create a regular expression or something like that to check the outputs. And well, I ran on this machine and now I ran on this machine and things don't match. Why don't they match? Well, they don't match because the order of operations on these things and the details of how numerical operations happen on these machines matter. And so that becomes very hard, very hard stringent constraint. So if your constraint is at that end of the spectrum, then you have to sort of take, you need even more provenance in some ways, right? That this model is run on this architecture with this number of cores, and if you do exactly this in exactly this way, you'll get exactly that result, right? So that's sort of the spectrum that I sort of think of these things.
So then in those type of, so then from the start, whatever your use case is, you should be deciding on the level of provenance that you need, or use reproducibility or replicability that you need.
Yeah, I think that's right. I think that everything should have some amount of reproducibility, right? If that model is being used for a decision-making process, right? So if I'm using a model for some decision-making process, then I want some level of reproducibility that this is producing a consistent, statistically averaged result, right? In some way, right? And that's how I would evaluate a molecular dynamics model. Is this tending toward, as I run this thing, right? As it's sampling, it's a stochastic problem, right? And so, and same thing with neural networks, right? It's a stochastic problem. So am I sampling, when I look at this space, am I sampling the correct, sort of probability space, so to speak, that the answer is correct? So I think, sorry if I'm sort of wandering here, but I think of these in terms of probabilistic sort of things, right?
No, but yeah, that's
probabilistic. And so, reuse, on the other hand, is like that the barrier to doing the reuse thing should be like minimal, right? That should be, I'm keeping track of my metadata. I'm keeping track of my version objects that are part of this thing. I'm using secure I think they're called secure tensors or whatever, the immutable sort of tensors for that Hugging Face has adopted for distributing the weights of their model. If in principle, so the other thing that's happening in AI Alliance is talk of how do we build sort of open catalogs. So if the data, this is back to the data, that the data is opaque, then it's hard to judge what these networks are doing. I can't even build statistical tests, right, in some way, right, because I don't know what the underlying token what the structure of that underlying data was, and whether it was copyrighted or whether it was all these other sort of implications, right. And so I think this is on everyone's mind is how do we start to connect those things up? And they're all sort of aspects of that sort of quote unquote reproducibility.
Right.
Right.
Yeah. But that's true. Like defining the language that we're all commonly using so that we understand what we're talking about is probably a good start.
And machine actionable, right? So the point of this is that, there's already sort of an adopted machine actionable language that, whether you know it or not, that Google sort of came up with along with Microsoft and everybody else, called schema.org. And so if you're a web developer and you want your web page to land high up in sort of the hits in Google search, you basically embed some metadata in your web page, and that vocabulary that's used is something called schema.org. That is reused, right? So it's the reuse of these things and linking to the common sort of vocabularies that's important. And so Croissant reuses essentially the data set vocabulary from schema.org, and they extend it, right? And then they say that my identifier for extending this is this thing, and you can now go and look up the definitions, right? Now I can it's sort of recursive, right? So I can then feed that in the models, have models check those sorts of things. The language models sort of understand these things, right? In some ways, pretty well. So yeah, it's all of these sorts of things together.
Mm-hmm. So yeah, establishing like the provenance, understanding what your need for the provenance and the goal, like if reproducibility means for your goal, I need to know what data we use. I need to know what model was used. I need to know what code is used versus I need the exact same results. Then I really need replicability. I don't need,
And that it tends to some value that some quantity, right, that is the correct quantity, right? So if it's a financial model, this thing should tend toward the correct, answer.
Yep.
How it gets that answer is in the details of the model itself, right? And so you can think of different ways of implementing a model that will sort of bounce around, but it's all going to tend toward an answer that should be the sort of correct answer, right?
Right.
As versus every step along the way, I should be able to compare these things and they should be exactly the same. So that's the distinction, I think.
Cool. So, well, I think we've definitely established the importance of regulation and standardization and how you guys are already dealing with this. One thing that came up in our tech rehearsal was like, we all got really excited when we got to the carrot and stick talk. Like, how do you actually make this happen within your teams, within your organizations? How do you get started? All of these things. And like some things that I've noticed just observing all of the community and just, what's happening in AI in general is there's like three things that are happening within this space that cause concern in implementing this. And one is that the technological advances far outpace any regulatory environment's ability to do something about it. So that's problem number one. Two, the dynamics in working in this space require such a constant in-depth learning of stuff that it becomes, to me, it seems like just like, yeah, if you're going to live the rest of your life and not do, constant absorption in this at all points of the day, like it's very easy for somebody to say, well, these type of issues are not my problem. I'm focused on this. Somebody else needs to deal with that. And then third, I've heard this multiple times, especially in the last year with everything that's been going on with AI and all the new models and everything, is that like, this topic is not sexy and we don't want to talk about it and it's boring and whatever. We need to focus on these bright, shiny things that are happening. So how do we incentivize these best practices and build, whether it's by, carrots or sticks, preferably by carrots, into our system so that, people are excited about creating these trustworthy systems going forward. And we'll start, well, we just ended with Charles. So let's go to Estefania.
it's not a simple problem, and I think there are many things mixed there. I think that it depends a lot on the problem we're solving, because when this type of problem is urgent, of course, we need something that works first, and then we can make it better and we improve our system. But I think that when we think about a problem that is giving us an answer in the long term, it's best to apply best practices from the very beginning. Um, it's I don't have a straight forward answer for you for those 3 points, because it's very context dependent. But something that I have seen that it it has happened in probably in every single scenario in my life, regardless of the problem I'm solving, and it's how easy, or let's say how fast, I can identify what I'm doing wrong. So what is the inaccurate data? What is the bad data practice I'm doing? And to give you an example, and I don't know if I mentioned this to Charles already, but my background for my PhD is in MD simulations as well. And the amount of data we generate is quite large. And I wish I had known about a tool like BBC when I was in my PhD. I don't think we had anything like that at the moment, but that would have simplified my life a lot. And that would have probably allowed me to find some more insights into the problem I was solving. So I think that if we can identify key risks and we can identify what we are doing wrong with the data and what are the best data practices as fast as we can, probably in the long term, we're going to have a more robust solution. Now, I think that there are many shiny things along the way, no matter which problem we're solving. But I'm a strong believer, and this is my personal opinion, that we should focus on one main problem at a time instead of just being dispersed. And there are many shiny things in this field. I mean, in general, when we talk about ML and AI, there are many shiny things. But I would like to sometimes go back to the basics. And to me, the basics is data. We cannot do anything without data. And even if I have very fancy GPU and super powerful computing time, it doesn't matter because my model won't be right. So I think that sometimes focusing on data, the quality of the data, how maintainable it is, and how reproducible it is, not even to have the very ultimate result, but to have from raw data to what I inject to the model, I think that is very valuable. And I find a lot of value into those first steps, which to me are the foundation of what we do. So probably I would just address the very first part step by step. And as you mentioned, it's not easy to start. I mean, it's overwhelming. But again, step by step, let's start with the raw data. Let's see what is wrong here. What I have is redundant or not. Should I clean? Should I standardize? And that type of small steps that will help us in every part of the pipeline.
Cool. Thank you. That was great. And thanks for addressing like how do you start, because that's super important. I think when anybody's looking at this, they're just like, okay, this is massive. Where do I start? Yeah. So cool. Alex, I let's go to you next. And like stepping from where you left off, which I love that you said, like, I'm not trying to make, a checkbox. I'm trying to help people be successful. So like, I really love that perspective on, addressing the carrot and the stick issue.
Sure. Yeah. I mean, I think the most important carrot to offer is to make it as easy as possible to get started. As Stefania was saying, like to take that first step and make sure that when people do get started, they experience some benefits from it. Like that's just human nature, right? I'm currently working with Mission Lane, which is a fintech in the credit card lending space to standardize their model development processes as reproducible DVC pipelines from end to end, and to make it easy to get started for data scientists on the team who come with a range of background and software engineering expertise. I think that the typical data scientist is a professionally trained mathematician, statistician, scientist, and a dangerous amateur software engineer. I know I was, right? So there's a learning curve there, and many of us who love software engineering best practices learned them from being exposed to code bases that where somebody who knew more than we did had put it all in place, right? So we've approached this by creating a project template that data scientists can use for any model development project that's pre-configured with DVC for data versioning. It's got a DVC pipeline skeleton with all the typical components of a model development pipeline. Also combines like GitHub Actions and PyTest for automated testing, Poetry for reproducible software environments. That's another, I mean, especially in the Python world, getting the same software installed on another computer. I've worked at places where they didn't use Python just because of that. And then tools like Rough or Black for code style standards. So, things that throughout my career, I've spent a lot of time in meetings stressing, you got to do this, you got to do this. You can talk about it till you're blue in the face, or you can give people, a cookie cutter project where all this stuff is already working, right? And so I think for standardization to work in practice, the standard has to deliver enough value that people want to use it, or you'll just be pushing boulders uphill forever. And so my work, I've always focused intently on making sure that data scientists who use these new frameworks enjoy it and feel like it makes them more productive from day one. But I mean, sticks are necessary too. I think the sad truth is that checking your work carefully is time consuming, and time is money, and you have to pick your battles wisely. And it can be very difficult to get, especially like non-technical leaders, to appreciate the importance of best practices without some kind of external mandate. Especially when the consequences of inaccurate analytics take a long time to manifest, like they do in lending. So what I've seen, one of the reasons that I valued the regulatory framework in banking is that it could give data teams the air cover they need to do the high quality work they wanted to do anyway, when their business leaders don't yet understand the importance of best practices. And getting to the sort of current excitement around generative AI, like this isn't the first hype wave that I've lived through in just my short, 15 years in this space. There's always something new, and I think we've got a sort of ongoing trend of lowering the barriers to entry to applying advanced algorithms to more and more kinds of data, more and more kinds of use cases. So inevitably, you're going to have newcomers who are excited, it's exciting, right? But who are going to barrel forward and do something without really understanding the risks. And that was the sort of thing that kept us awake at night in our risk management function. Like, is there somebody in this giant bank who's going to, build a chatbot that says racist things to a customer, and it's going to like get into production without us finding out about it first, right? I'd be way more worried about that today than I was in 2020. But that's the kind of thing. So I think having that risk management mindset is really key as well. If you advocate for best practices using a bunch of technical jargon to a non-technical business leader, they're not going to listen to you, and it's not their fault, right? Because you're not communicating effectively. But if you can really highlight and as much as possible quantify the worst case scenarios that can come from analytical errors, and then expose them to real world examples where these things have happened, it can be a lot more persuasive. So
speak in their language so they can understand. That's know your audience. Always a good thing to help you. So Charles, we'll let you talk about sticks and carrots and sticks.
Yeah. So first of all, ditto both the previous speakers. I mean, I think data-centric AI is really important. So Internig has shown that you get a lot better performance by making your data sensible. So you can get 40-50% gains in terms of reliability of a model depending upon, looking at the data versus looking at different ways of fine tuning the model, right? So that's a pretty good carrot right there to go and do things. I think, lowering activation energy. So what we did in the Trusted AI Frameworks project is exactly this. So build, sort of GitHub templates that you can you do cookie cutter that basically scaffold projects in a reasonable way that then can sort of provision the computational environment with the sort of tools that you want to use, DVC. I like Fast AI for my students, gives them really good guardrails to do some interesting things. MBDev for creating, taking the notebooks into a pipeline and producing code that can run, and can be taken by software engineers and refined, and automatically producing documentation. So automatically producing documentation from the notebooks and the code, I think is also a vital part of that process. Okay. The thing I'd like to touch on, I heard sort of from both of the previous speakers, was organization, right? And so carrots and sticks are in the eye of the community that you're sort of part of, right? At least from a science perspective, right? And so I can give a couple examples of this. So back in the Wild West 1990s, and actually I think even before that, the protein crystallography community decided that we should have a repository for all these protein structures, right? These are valuable things. They cost a lot of money. If you know anything about creating, elucidating a crystal structure for a protein, they can consume an entire graduate career, right? So you come in, your advisor gives you a crystal structure that we want to look at least in the old days, and part of that big chunk of what your dissertation is going to be is doing that crystal structure. So these things are expensive, right? And so at the time, there was no real community for sharing these things or for understanding the underlying things. So they created something called the Protein Data Bank, and a standardized format for essentially depositing your crystal structures. Now, the carrot is pretty obvious here, that if somebody puts a crystal structure in the repository, I can use that for simulations. It was used by AlphaFold for basically creating this really interesting neural network that can predict, protein structures, static protein structures incredibly well, like revolutionizing science. But the stick was that they got the publishers to come in and say, well, as part of the publication process, when you submit a paper that has the crystal structure, right, you need to do this, right? And we're going to expect that crystal structure is there. And if it's not, we're not necessarily going to publish your paper, right? And so that's one way of putting sticks. National Science Foundation is, and other government, research organizations have these data management plans. And so up until this point, they've sort of been advisory, except for certain communities. So there's certain communities in the, polar climate realm and some of these other places where, as part of getting an award, getting the money, right, you agree that you're going to put your data into a particular repository. If you don't do that, there may be a stick of, well, we may actually look and see if you've done that when you try to go for a renewal on this grant, or you try to apply for a different kind of grant.
We may actually look, or we're going to actually look.
My understanding is they actually did look, at least from that directorate. So if you applied back to that directorate, they expected stuff to be there. If that's not universal. So and review committees, if you've ever been on a panel, I mean, usually that's the farthest thing from your mind. But part of the discussion is, how do we start to standardize that, right? As a stick, and have like real world consequences that, you may have to write a letter of apology and a plan of how you're going to rectify this in the future and make sure your data ends up in the right place if you want to sort of get off the naughty list or something like that. So, I think there's a variety of ways depending upon the community. I think I tend to favor community-driven efforts because, this idea of carrots and sticks is sort of in the eye of the beholder community. Scientists should come up, as a chemist, right, or a subfield of chemistry, say protein, crystallography, you should have the freedom to come up with what this sort of means for you, right? Within some sort of a framework and guidelines, should meet some set of requirements. But you as a community should be driving this, and that's what the fair is actually, the FairSharing.org and everything else is actually structured like that, structured by science domains, right? And so the Earth Science community, they may have a different idea of what this means than say the high energy physics community, or the geosciences, or whatever, right? And so they should figure out where the data should go. If there's a centralized repository, or there's not, or the publisher is in charge of this, or how, and it's this community, right? That then the community is the key part that I wanted to come back to, is that the community has to come to agreement, and they can set best practices. So part of the lowering the activation energy is like, well, I wish I had known DVC had existed. Well, there should be a community, as we're part of right here, right? That's sort of evangelizing in some way, that there are these tools, not just DVC. There's other tools that allow you to do this. And so it's not just that it's the carrots and the sticks, but the community can do the evangelizing of this is how you actually do it and lower the activation energy. That said, also, I think tools and AI can also lower the activation energy. So some of the projects we have right now is how do we build co-pilots that could potentially help us with these things, right? And so it, the metadata is there. It can read and write the metadata. It can check to see if I'm following some sort of set of structure. It can suggest and warn me that I'm not, or give me suggestions. So I think there's all of these sorts of things that can sort of play a role in this.
Cool. Lots of topics for other meetups. This is really great. I want to say yay, community for the win, but we're almost at time. So I just wanted to do one last quick round of each of you of like, how do you stay abreast on these topics and regulations that for Stephanie, I'm sure it's like, yes, we need to pay attention to the FDA, but are there any other resources that you guys each go to that help keep you up to date and knowledgeable on these issues? And we'll start with Stephanie.
Yes, of course. I think one valuable lesson I got was to keep an eye on all the open source community, the discussions. It's open source. You can just go and read. It's just a discussion. And it's incredible to see how much you can learn only by reading one discussion, one issue, see how someone is doing a PR, introducing a new feature, that type of things, but also the type of open source talks like organized by PyData, where there is a ton of information to extract there. And for every single package from Python, there is an event. And usually they have very interesting talks about very interesting tools and approaches. That is one option. Also, it's really hard to keep up because while working and discovering, there is almost 24 hours a day. But what I try to do is to just follow cool projects on LinkedIn, follow them. Also, sometimes I subscribe to bulletins, and then I just read newsletters, that type of things. And of course, I read scientific papers where usually academics publish their work. And even if it's just unofficial and not yet peer-reviewed papers, I just go to archive, and sometimes I read one of another PDF.
Cool. Lots of reading there. Cool. Thanks for those tips. And Alex, how about you?
Well, I'll sort of dodge the question and say that I actively suppress the anxiety to feel like I have to keep track of all of it. Sort of like I suppress the anxiety to read everything in the news. I think the risk-weighted mindset that I mentioned a few times, I think is really important, where it's very hard to solve these problems in the abstract. Keeping your focus on the use cases that you're responsible for, and putting the time and energy to say, like, what really matters here, right? And then dig into the details in the places that matter most.
This is a reminder.
Oh, excuse me, one second.
Baxter,
My
Of course.
Alexa reminded me to feed my cat. 12 o'clock, and we're done.
Important too.
Yeah, so it's a similar answer to Estefania when it comes to finding a solution to a problem at hand. I have a network from my years in financial services of folks who are sort of grappling with evolving regulations. I'm really interested in sort of moving into other industries that are starting, at an earlier phase of that trajectory. Where I think we'll see a lot more regulatory frameworks for AI emerging as the use cases in society become more and more impactful, and we start to understand what the risks are. And I think working with teams that are interested in getting ahead of that curve is something that excites me, and hope I'll get the opportunity to do more of. Awesome.
And Charles, a couple of good resources. You've given so many today, like AI Alliance, but any other ones?
Yeah, so for scientific data, the Research Data Alliance, RDA, is an organization. It's an internationally funded organization. So it's funded by United States research organizations, National Science Foundation, National Institutes of Health. NOAA, I think, has kicked in money to start it, but it's also funded by the EU, by Japan, it's a international organization that is worried about research data and AI models and all these things and how they sort of apply across domains. I think, one of the forerunners that I've worked with pretty closely in the past is the Earth Science Information Partners, ESIP. So this is another one of those communities that has been funded by NOAA and NASA and USGS and everything else to sort of talk about in the earth sciences the data and how to structure these things and how to build these crazy things called ontologies. They have an ontology called SWEET, which was built by NASA, and are worried about this, AI reproducibility problem also. And so these are, sort of structured topical groups. They have, sort of working groups, working areas with all of these different topics that you can sort of see and look at what the product outputs of these things are as resources, and they're on social media too. And then, like you said, I think there's some really interesting things that are happening with the AI Alliance that in the next couple of months, I think that there'll be some pretty interesting, sort of white papers. I think these are going to be championed by the sort of big players like Hugging Face, like Kaggle, like, Meta, like IBM. I think getting, that sort of corporate, that sort of buy-in to help, build that community and keep it sustainable, I think is also important. So those are sort of, the places for research data and AI data that, think about.
Cool. Great. Well, I want to thank you all for being here today. This was amazing. This definitely goes to the top of my favorite meetups that I've had. It was really great. There's so much food for thought for our community and how to do things with the best practices, and how to go deeper and how to actually get things set up, which is, the name of the game. How do we actually accomplish this? So I want to thank you so much for being here. Thank you to everyone that was here today. The video will be on YouTube as usual. Our next meetup will be, I believe, DVC and Ray, using them together. And that's all for today. Thank you all. Until next time, we'll see you around.
Thank you. Be well.
Bye.
Thanks so much.